Hello, Algebra 2 students. This is a video on 1-4b talking about compound inequalities. So our goal here today is to be able to write them and know the difference between and or and what they look like on the number line when we graph them. So I've got a couple of quick notes here for you. Go ahead and take some time to write these down. I'll read them to you for those of you that like to hear it. So a compound inequality is joined by the word and or the word or. The and type of compound inequality must be true for both inequalities. So you're greater than 1 and you're less than 7. So something like that. It would be an and between those two inequalities linked together. Compound as in put together. And then the or must be true for at least one of them. And we often split the line on the graph. It flares out towards infinity. And I'll be doing examples of these. So after you've got those written down, if we just kind of compare, here's the and kind, and here's the or kind. So the compound inequalities that are and typically are a segment or a chunk of the number line, versus the or tends to be two rays going in opposite directions. In other words, they flare out towards infinity. Both are true, just like in those definitions I have above, and here either one has to be true. Both do not need to be true, so either. And then some weird times, if we say x is greater than 1 and at the same time x is less than -2, we could get a null set. So it's possible to get a null set with the and kind of inequalities. And with the or, we could actually get all real numbers. If we said x is greater than 1 or x is less than 2, that would cover every single possible real number. And so when we look to graph them, like I said, it's a chunk. So we'd have two crucial points. Whoops, let me move that up. Say it was 2 and 5. If it was an and kind of compound inequality, we'd have dots or circles on those crucial points, and it would get filled in, would look like this. The or kind, that flare out idea that I was mentioning, if we had those same numbers 2 and 5, so this would be x is between 5 and 2. That's typically how we write this. This is the fast way of saying x is greater than or equal to 2 and x is less than or equal to 5. If we had those same crucial points with an or kind of problem, typical one, we'd say x is less than 2 or x is greater than 5. And so that's what I meant by flaring out towards infinity versus it being a segment or a chunk of the number line. So I've got 3 examples for you guys just to go through here quick, and then I'll let you get going on your homework. All right, first example, this would match up with example 4 in the book. Get that straighter there. And then it would be given like this. 2x minus 1 is less than or equal to 3x, and x is greater than 4x minus 9. So when you do these problems and they're given to you like this, we're going to do each one separate and then put them together at the end. So this is just a two-stepper. I'm going to move this 2x over to the other side by subtracting it away. Goodbye 2x. Now you get -1 less than or equal to 1x. Just a second here.
Hey, I have a question. What time does this class start?
Sorry about that. I had to get out of a meets here. And so I've got division by 1 here, which doesn't change anything. So I'm going to write this, reverse it just so the x is first. It's my preference on these kind of problems. -1. So that's part of my answer. This is a compound inequality. So now I'm going to have to move this 4x over to the other side. And I get a -3x greater than a -9. Now here's where we run into trouble with inequalities. Stupid line solving, solving an inequality is just like equations, except when you multiply or divide by a negative. So here I'm dividing both sides by -3, and so we have to remember to flip our inequality. All right. So now these two are connected with the word and, so x is greater than 3. Whoops, I didn't switch it. X is less than 3. See, I almost made that same mistake that happens all the time. And at the same time, it has to be bigger than or equal to -1. The easy way to do that is just to put x between the maximum amount, which is the 3, and the minimum amount, which is the -1. So there's your final answer. So we don't write the word and in the final answer. It's implied when we put it between the left minimum number and the right maximum number. And so then the picture that would go with this one would be a chunk between -1 and 3. And then we still have to do that dot or circle thing. So this has got the equal sign underneath it, so it's a dot. And this is a circle. And there you have it. Final answer. All right, that's 1 of 3, so I've got 2 more to do here. Next one here, let's get this lined up better. Example 5. This is an OR kind. So we have 2 separate inequalities again. 3x plus 9 less than a -3, or -2x plus 1 is less than 5. And I'll just do each one separate and then connect them with the word or at the end. So -9 minus 9, I get a 3x less than. Subtracting doesn't flip the sign, if you were wondering that. It's only division or multiplication. And so we're putting these two together, keep, change. If that helps you, we get a -12 there. And then divide away the 3, and I get x is less than -4. And then I'll go and do this problem as well. So subtract the 1, I get a -2x less than a 4. And now I'm dividing by a negative number, so that's going to reverse the inequality symbol. So here I'm going to get an x is greater than -2. The word or is connecting them. I didn't write it every time, but you could. And so this is your final inequality. They're solved for x. And then the picture that would go with this, I'd have the -4 as one crucial point, the -2 as the other crucial point. They're both open circles, and the less than -4, less than goes to the left, where the numbers are smaller than -4, and x is greater than -2, that goes to the right. So this is our typical or kind of compound inequality where it flares out to infinity. All right, one more to go here. So this is example 6. This one now is going to start you off with it already in compound inequality form for ands, but it's got some solving to do. So when you're given a problem like this, it's as if there's 2 stupid lines. In other words, you can solve this 2-stepper, but you're going to have to do it both to the left number and to the right number, and you can do them simultaneously. So I like to call these 3-column solutions. So I'm just going to subtract 3 from all 3 columns. I'm going to subtract it from the middle, and then what I do to the middle, I have to do to the right and the left side. So then I get a negative 12 over here on the left. The 3's cross out, and I get just a 4x in the middle. And then I get a positive 8 when I do 11 minus 3. And then I divide away the 4. Now you might be wondering, well, do I do flippy because it's negative 12 divided by 4? The answer is no, because I'm dividing by a positive 4. So it's what the coefficient of the variable is. If that's a negative number and you're dividing it or multiplying by the reciprocal and it's negative, that's when you do flippy. That's when you reverse the symbols. So no flippy on this one. We get negative 3 less than x less than or equal to 2. And there's our final answer for the inequality. And then the picture would be a chunk of the number line, a segment with negative 3 and positive 2 as our crucial points. Negative 3 has a circle, open circle on it, and 2 has a dot on it. And then I would fill in between, because all of those numbers are solutions. All right, good luck, and here is the assignment. I should have had that handy here. Sorry, give me 1 second. If you're ever wondering what the numbers were, you didn't write them down or you didn't hear, they're on my Google Classroom site. Just go to the WAG and it'll take you to all the homework assignments and page numbers and such. So these are page 29 to 30. And it's 18 through 28. Even. Wait, no, not even. Sorry, it's not even. 37. And then 41 to 50. All right, good luck. I'll see you soon.